Now we're going to talk about electrostatics. What I want you to do on your sheet of paper is to draw a picture of the atom with all of its parts that you can think of. And so, a simulator or a model of the atom. So go ahead and pause the clip. Go ahead and do that, and then when you're ready to check, you can hit play to continue. All right, so we should have protons and neutrons in the nucleus, and then we have electrons surrounding. And this is definitely not to scale, right? We know the atom is mostly empty space, and the electrons have much less mass. They're much smaller than protons or neutrons. Okay, so let's say we had a balloon and we had some tissue paper, and we charged the balloon up, so rub it against our hair, against our shirt, and we bring it close to neutral tissue paper. What's crazy is that the tissue paper will actually start to come off the desk even though it's neutral. And so, yeah, what we did in class was to talk about that, why would that neutral tissue paper come up into the air? And what we have is the fact that that tissue paper, if we draw the tissue paper, is neutral. We have our balloon, which if we have friction, it's negatively charged. And we bring it close to the tissue paper, and what happens is we know that the tissue paper is made up of a lot of atoms. Those atoms combine together to make molecules. And so what a molecule is you have, let's say you have a nucleus here, you have a nucleus here, and let's say these are electrons that are being shared between them, right? So what'll happen is if you bring like a balloon close to these atoms, those electrons are going to want to spend more time on this side of the molecule. And so what happens is the electrons shift to this side, leaving the other side more positively charged. And that's actually what's being attracted up towards the balloon. All right, so for the atom, we have the positive charge in the nucleus, and that positive charge cannot move from the atom unless there's a nuclear reaction. And that's a really important part of electrostatics. The atom has a negative charge in the electron cloud around the atom, and electrons can move from atoms or one atom to another depending if they're conductive or conductors, electrical conductors or not. And so if we return back to this issue with the the neutral tissue paper being lifted up, what I described there earlier was that the molecules are what's called polarized. And so some of the electrons move away from the surface, and some, and leaving really the other part positively charged. And so the electrons kind of shift down, and the leaves the surface positively charged. And so the electrons move down, the surface, is more positively charged, and it's attracted to that balloon, which that balloon is negatively charged, and so the balloon paper lifts up off the table. So electrical conductors are where electrons are bound loosely and can move freely in a material. Copper is used extensively in circuitry, and there's a good reason for that. Copper is readily available, it's not expensive, and it's a good conductor. Insulators, on the other hand, are where the electrons are bound tightly to the nuclei, and so there's few free electrons to move from atom to atom. Plastics are great insulators, and if you look at really any wire, electrical wire, they're going to be coated with, a coating or plastic around it to protect the person touching it. One of the things that is important to, just on a kind of an extension to understand, is the triboelectric series, and why things are more or why things shed electrons or take on electrons. We know that with balloons, if you have friction in a balloon, it's going to take on electrons. If you have glass, glass is going to shed electrons with friction. And this paragraph explains some more of that. So if you want to pause the clip, you can read that. And here's another paragraph explaining this process here.